Welcome everybody to Characteristics of Linear Relations Lesson 3. So I know it's kind of weird that we are starting with Lesson 3, but again with this shortened class schedule, we have to skip a few lessons, so stay with me and it shouldn't be too bad. So we've been looking at relations and we've been looking at functions, and we know they create graphs, and now we are starting to look at linear relations, which form straight lines. And so now we need to start looking at characteristics of those lines. So today we're going to be looking at the slope of a line segment. So the slope of a line segment right here is the measure of the steepness of a line. So however steep a line is going to be the slope. There is a mathematical way to calculate that, and we are going to use slope is equal to rise over run. So we know that the word rise means up or down, and run means across. So if the rise is positive, we count up, and if it's negative, we count down. If the run is positive, we count right, and negative, we count left. So the easiest way to remember that is just like our graphing or our Cartesian plane, the y, which is the rise, right, up and down, it's positive going up, negative going down. And the x, which is the run, is positive to the right and negative to the left. That's the easiest way to remember that. So it's just like the Cartesian coordinates. All right, so let's actually see this in practice here. So let's look at line segment AB. Let's use blue. So the first thing we want to look at for line segment AB is the rise. So what you want to do is we're going from A to B to B. It's just buttons I keep pushing buttons on my pen. So we're looking at the rise. So if you start from A, we have to go up 1, 2 jumps. We're going up 2 jumps, so it's plus 2. The run now from here is the change in the x direction or the horizontal direction. So now that's going to be 1, 2, 3, 4, 5, 6, 7. And that's in the positive direction. So plus 7. So if we do rise divided by run, we know the slope of that line is 2 over 7. Sorry, that's not a very nice 2 over 7. 2 over 7. And that's slope right there, which is really nice. We can look at slope or line segment CD. So we're starting at C and we're going to D. So let's look at the rise first. Well, now we actually have to go down 1, 2, 3, 4, 5 jumps. So we went down 5, which is negative 5. And our run now is going to be from there. We're going to go 1, 2, 3, 4. So that's a run of 4, but it's also to the left, which is our negative direction. So now our slope is going to be rise over run, negative 5 over negative 4. But if we have a negative over a negative, it makes it a positive. So the slope is 5 over 4. I mean, you could have easily gone from D to C and calculated your 1, 2, 3, 4, 5 as your rise, and 1, 2, 3, 4 as your run. Either way, it's either going to be positive and positive, or it's going to be negative and negative, which will create a positive. And now we're going to look at EF. So just going to erase this here. We're starting from E and we're moving to F. So the rise, the first thing we're going to do is the rise. So it looks like we're going to go 1, 2, 3, 4, 5. So that's going to be negative 5 for our rise. And our run from there is going to go 1, 2, 3. but that's in the positive direction, so we can just write 3. So in this case, our slope is going to be -5/3. And if it's just one negative, it stays negative. That is slope in a nutshell. We are going to go on to do some other examples here and explorations, and hopefully it'll make a lot of sense by the end of it. So we've got a line here on this graph, and we've got a few different points on that line. We have A, B, C, and D. So we are going to look at calculating the slope between a bunch of those different points. So the first one we're going to do is between A and B. So if we look at the rise there, it's a little bit hard to see, but the rise we're going to do is 1, 2, and the run will be 1, 2, 3, both positive. So that is 2/3. Now we're going to go from A to C. So we're going to go all the way up from A all the way up to this point here. So if we wanted to do the rise, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we'll have a rise of 8 and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And a run of 12. So that means that slope is 8/12. Let's do one more. Let's do BC. So if I were to do BC, going from B to C, so I'm going to say my rise is 1, 2, 3, 4, 5, 6. 6. And my run is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So I have 6/9 as my slope, rise over run. Before we move any further, I want to reduce these fractions. So 8/12 actually can reduce to 2/3, and 6/9 can reduce to 2/3. That's supposed to be a 3. So what you can see here is that, excuse me, that all of the slopes are going to be the same. And that hopefully makes sense, because if you look at this line here, and let's use the highlighter. If you look at that line, it's the same steepness all the way through, whether you measure it between those 2 points, or between these 2 points, or between those 2 points. It's always going to be the same slope. The slopes are related. They are the same. That's how they're related. It's the same straight line. Doesn't matter which 2 points you choose on the line, the slope will always be the same. So it says, that kind of sums it up right here for you. The slopes of all line segments on a line are equal. The slopes of a line representing the graph of a linear relation can be found using rise over run for any 2 points. Any 2 points on the line. Just deletes all my stuff. So that's pretty cool. We're going to go on to investigation 2, slopes of horizontal and vertical lines. This is where things get a little bit weird. So we're going to do one slope from grid 1 and one slope from grid 2. That was supposed to be a different color. Okay, well, let's do slope of AB right here. We're going from A to B. And we know slope is rise over run. So what's the rise if we're going from A to B? Well, the rise is 0, right? We're not going to go up or down. And the run in this case will be 1, 2, 3, 4, 5, 6, 7, 8. It doesn't really matter what the run is. 0 divided by anything is just 0. So basically all horizontal lines, all lines that are completely flat, have a slope of 0. Hopefully that makes sense. The steepness is 0. And on the other side of it, we're going to look at vertical lines. So we have rise over run. That's how we do slope mathematically. So let's look at line JI. So we're going from here to here. my rise is going to be 1, 2, 3, 4, 5, 6, 7. And my run, well, it's 0. We're not going either way, so my run is 0. And if you ever have tried to divide anything by 0 in your calculator, you are going to get error. You can't divide by 0. My math teacher used to tell me that the world will explode if you divide by 0. I don't really know what she meant by that, but I always remembered it. I'm not 100% sure why. So the slope of a vertical line, we always say, has an undefined slope. Undefined. We can't define it. So horizontal, 0, vertical, undefined. Cool. This is going a lot quicker than I expected, so that's fantastic. We have 1.5 more pages. So we're going to start looking at positive and negative slopes. So I'm going to find the slope for all 6 of these lines, and then we will figure out what's going on here. So for line 1, what you want to do to find the slope is you want to find 2 points on this line that will be exact points. What I mean by that is maybe right here, that point on line 1, I can write exact coordinates for. I know that it's 0 and 2. If I were to choose something like this point right here, well, it's kind of in the half, right? It's between -2 and -3, and between 0 and 1 in the y. And so that's going to be a really weird and annoying point. So what you want to do is you can choose any 2 points on the line, but they have to go through whole integer numbers, if that makes sense. So looks like I can use, go away. There we go. Looks like I can use that point right there. And so now I can say, well, my rise for this is going to be, the easiest way is to start with the leftmost point. And then you can say rise is going to be +2, and run will be 1, 2, 3, +3. So my slope is going to be 2/3. Let's do line 2. So now we need to find 2 points on here. It looks like maybe right there and right there. So my rise, start with my left point, goes 1, 2, 3, 4, 5. And my run will be 1, 2. So +5/2. And then we'll do line 3 as well. Looks like I can go choose that point right there and that point right there. And I can say my rise is 1 and my run is 1, 2, 3. So rise over run, remember rise over run gets me 1/3. Now let's go do the other lines. Yay! So let's do line 4. Let's find 2 points on line 4. Looks like 1 is right there and 1 is right there. Looks like we could have chosen this one as well if we wanted, but for now we just need 2. So my rise is -2 because we're going downwards, and my run is 1, 2, 3. -2/3. And let's do line 5. So the points I can choose, looks like there's 1 there and 1 here. So my rise is -1, -2, -3, -4, -5. And my run is +1, 2. So -5/2. And line 6 is going to be, it looks like there's a point right there and a point right there. So my rise is -1 and my run is 1, 2, 3, 3. That was weird. Compare the slopes of line 1 and line 4. Well, they are the same, but one is negative, right? 2/3 and -2/3. And it's same all the way down, right? Line 2 is 5/2, and line 5 is -5/2. So what we're trying to figure out here is a line which rises from left to right has a positive slope. And a line which falls from left to right has a negative slope. So if you're going up to the right, that's a positive slope. And if you're going down to the right, that's a negative slope. And I always imagine this, and this might be silly, but some of you might like this, is I used to play a lot of those like two-dimensional Mario games, like Super Mario when I was younger. So I always imagine that those two-dimensional games work left to right, always. So I imagine if Mario's running up the hill, it's a positive slope. And if Mario's running down the hill, it's a negative slope, right? Because you're always working left to right. And sometimes the screen would even move, and if you got left behind, you would die. So it was like, I don't know, just an easy way for me to remember, but you find your own way. Up to the right is positive, down to the right is negative slope. Okay, I'm going to skip this question, but I'm going to look at this example right here, class example 3. It says draw a line segment on the grid which passes through the point -4, 2 and has a slope of -2/3. So the first thing I'm going to do is I might actually zoom this in. Maybe I'm not going to zoom this in. View, zoom in, just so the graph is a little bit nicer for you. I wonder if I can zoom one more time. Oh, there we go. Look at that. I'm like a tech genius. Okay, so the first thing we're going to do is plot our point, -4, 2, because we know for sure that the line goes through that point. So we know that's our x is -4, -1, 2, 3, 4, and at +2y. So we have a point right there. Now we have a slope of -2/3. So I just want to remind you that -2/3 is the same as -2/3, which is also the same as 2/3. So if I were to plot -2/3, we know that's rise over run. So I will graph that. -2 means a rise of -2, which means it's -1, -2, and a run of +3. So +1, 2, 3. And then we're going to put a point right there. And so now we can draw our line. Oh, that was bad. Wonder if I can insert a line here. Through there, kind of. Right there. Nailed it. So what happens if we were to do the run as a negative and the rise as a positive? Well, I'll show you. So here we would start with the same point and we would go, okay, we're going to have a rise of +2 and a run of -3. So we're going to go this way, 1, 2, 3. And we put a point right there. Well, it's actually the same line. Look at that. That would connect into the same line. So whatever place you put that negative, you're still going to get the same answer. Put it in the rise, put it in the run, you'll still end up getting the same answer. You only need 2 points to be able to graph a line, right? We were able to graph a line with these 2 points because the slope's always going to be the same. So that's that, right? So if you have a question like this, it says it goes through this point right here, draw that point or plot that point, and then count from that point your slope. And then plot another point and draw your line. That's awesome. Okay, so here's a question. A line segment has a slope of -5/7 and a rise of 12. Calculate the run as an exact value. So we know slope is rise over run, and we know that our slope is -5/7. We also know that our rise is 12, and we don't know the run. So we've got an equivalent fraction here. So what we can do is either use algebra to get x by itself, or we can cross multiply and divide. I don't know if you remember that. So whenever you have equivalent fractions, one fraction equal to another, you can cross multiply. So you multiply the cross pair that are actual numbers, 12 times 7, and then you divide the spare. Multiply the pair, divide the spare. So what you end up with is 12 times 7, which is 84, I believe. That makes sense. Divided by 5. I feel like that should give us a whole number. I must be crazy. No. So 84 divided by -5, which is our spare, which means our run is -84/5. And we'll just leave it as a fraction. If that throws you off, if that's weird for you, just let me erase that so I have more space. You can say, okay, -5/7 is equal to 12 over x. We want to get x in the top of our equation. We're trying to get x by itself, so we multiply x to both sides. And then I'm left with -5x over 7 equals 12. And then I can multiply 7 to both sides. So that cancels out. I'm left with -5x is equal to 12 multiplied by 7. And then I finally divide out -5. And those will cancel out. And I'm left with x being 12 times 7 divided by -5. 12 times 7 is 84 divided by -5. So you get the same answer. All right, I think that's pretty much it. We're going to get on to the assignment. So just remember, slope is equal to rise over run. Don't forget to like and subscribe, and have a great day.